So, thank you, though. You have a good point. Could I ask everybody who, unless you have a question to ask, to mute your mics before class, please, so we get as good a transmission as we possibly can. Okay, we're ready here. Oh, 2 minutes. Okay. Just an interesting note here. I don't know if any of you noticed this, but Teams is about the most intrusive software I've ever owned. You'll notice that you're not on Teams. You have no intent to be on Teams, but yet if you look at your, if I come down here, for example, and I do my task manager, you'll see the Teams here. And I tend to notice that Teams is there all the time. I don't start it, and it's there anyway. So it's running in the background, and it seems that it chooses its own time when to run in your background. Not that I chose it, but I just find it there. And you know, some of us, I don't have the newest computers, so I like to keep my my C drive as uncluttered as possible. I have a RAM drive, or a solid state C drive, but it's not that big. And so I try to keep software that I'm not using out of it, but Teams just comes on whenever it feels like it. It's just interesting. And then once I log off, so when we finish class here, I'll log off Teams, but it will still be there in the background. So I don't know if you have a computer that's kind of running on the edge, you might just, again, check your task manager. And if you're not on Teams and you don't want to use Teams, just come over here, give it a right mouse and say end task, and that's the only way to eliminate. There's another one I use malware software called Malwarebytes, and that one comes in on its own too. All right, well, let's begin class then. All right, and we find that, okay, this is where we left off. We created these profiles, and the purpose of this exercise was to identify 3 distinct areas, and the first being from 0% to, and it turns out that's the crossover, that's what this is, 13.44%. So in this area, we would choose the large investment. Between these 2 lines, I will choose the smaller investment. And then the third area is to the right of this blue line that's out here. And what's significant here? This is, oh, I got this way off. I didn't realize that. I guess it's actually, it's hard to tell, but it's crossing right about here. It's discount rates in excess of the IRR of Project S. So at discount rates of, say, around 35% or greater, I would reject both of these projects. So we can, yeah, so this is kind of, if you look at the lecture notes, this is what it looks like. So choose L between a 0 discount rate and the crossover, between the crossover and the IRR of the S project. We'll choose S, and then finally out here we'll reject both. Okay, Oops, go there. Anybody need this? Any questions on any of this that I can answer? Let me check in real quickly. Let me turn on my chat just to see anything. Okay. Any questions so far? All right, let's continue then. We'll now get into some of the problems that we have to work through with the IRR method. Okay, so we've done this. Yeah. Okay, now IRRs, according to a survey, said that companies use the IRR method, they said equally as frequently as they use the NPV. And unless you have projects that are competing for the same capital, that will work. That's not an issue. When you if you there's no such thing as choosing between projects by choosing the highest IRR. There's no such thing. You can rank them according to IRR, but you don't choose between them. And that's why we run into this problem. Let's just point that out real quickly here. So if I have a discount rate of 10% and I choose the project with the highest IRR, I have reduced the value of my shareholders' wealth by the difference between these two lines, haven't I? Right? So you don't choose between projects based solely on the IRR. If all of your projects are independent, that is, they're not competing for the same capital. In other words, choose one or choose the other. And if they're just simply independent, you can fund them as you go. Well, then the IRR works fine. Just pick any project that has an IRR that exceeds the cost of capital. Simple rule, nice to work with. Okay, it's when you get competing projects that you run into difficulties with the IRR. All right, and let's see which one I'm working with here. Okay. We did most of this. Yeah, so here's some limitations there. And one of them is the IRR doesn't tell you what side of the transaction you're on. So if I give you these three cash flows, minus 1,000, 500, 750, your IRR is 15.14%. If I alternatively show cash flows as a positive 1,000, negative 500, negative 750, the IRR is exactly the same. Okay, so I would be indifferent between these two projects if IRR were my sole criteria, wouldn't they? They have the same IRR. That's why you can't choose between projects using the IRR, because look what happens. If your cost of capital is 10%, you're far better off with project A than you would be with project B, correct? So the IRR basically doesn't tell you what side of the transaction you're on. So for cash flow A, you're basically a borrower. You're borrowing 1,000. You're paying back 500. You're paying back 750 at the end of year 2. Okay, IRR is 15.14, obviously. And then here, you are providing capital for someone else of 1,000. I'm sorry, forgive me. This is a cash flow to you. It's a positive cash flow. So you have borrowed 500. Here you loaned 100,000, 1,000, sorry. You loaned 1,000 and you receive cash flows of 500 and 750. That's a very good investment. In this case, somebody pays you $1,000 today and you have to repay 500 and 750 over the next 2 years. That's a very bad investment. But the IRR won't tell you that, will it? See, it doesn't tell you which side of the transaction you're on. Okay, and another issue is the uh, issue of multiple IRRs, all right? And in both cases, I guess we can use Descartes' law for some clarification here. Well, Descartes' law says that the number of possible solutions is equal to the number of sign changes in the cash flows. Okay, let's go back here for a moment, just to clarify why did we not have an issue here? Well, it's that's a negative, but that's no sign change. Now, going from negative to positive, that's one sign change. Positive to positive, that's not another sign change. So even though we have two negatives here, we have but one sign change, or but one IRR. Does that seem? Can we unmute our mics if we're not asking a question? Again, you can feel free to make a comment or a question anytime you want. I have no issue with that, but otherwise keep your mics muted, please. So Descartes' law basically tells us that the number of possible solutions to a problem is equal to the number of sign changes. And so let's go back to here. Okay, and it's kind of interesting. When I did my qualifying exams, you have to take an oral exam in a doctoral program, which any faculty can ask you any question, even though you never had them for a class. And so some guy threw up a question just like this one on me, and he said, explain how many IRRs you have, and I explained that very nicely. I said I have minus 800 plus 5,000, that's one IRR, plus 5,000 to negative 5,000, that's two IRRs. There's two possible IRRs here. And this was not the problem he gave me, but he gave me a different one. And he said, well, how do you know which IRR to use if you have more than one? And I just think it was probably one of the worst answers I've given to anything in my life. I told him use the one that's closest to your cost of capital. All right. And would that lead me to a correct decision here? Well, you can see that the IRR is 25%. Should I say that's a valid IRR for this problem? Well, look what happens when R is 10%. That, say my cost of capital is 10%. That suggests very strongly that I should be accepting this project. And you can see the NPV method points out immediately that this is not an investment that should be funded. So I'm going to say that I gave this person a very bad answer. But there are just some things in life that are undeniable, and that would be that if you are in somebody's favor, they'll treat you differently than they would be if you're not in their favor. I happen to get along with all the examining faculty very nicely, and I was very happy to fully admit they know more than I do. Now, I had a friend who was an accounting PhD, or he was going for his accounting degree, and he was a practicing accountant for 15 years before he ever went into the program. So they started asking him questions. And what does he do? He answers every one of them, not only every question, but answers the question and then tells them where it comes from. I mean, where do you get the rule, or how does it work? And they kept getting the questions harder, and that poor guy just kept answering them even better. And so my oral examinations lasted maybe 45 minutes. Okay, he was now into his third hour, and he's still answering every question and absolutely smoking it. And so finally, one of the faculty members grabbed him and said, "Can we take a break? I have to use the little boys' room." So he grabbed him out in the hallway and said, "Just get one wrong, would you?" And so the next question he was asked, he kind of said, "Well, I'm not real sure about this one," even though I'm certain he could have answered it. And so they said, okay, well, they finally ended it and blessed him and said, you passed your orals. So sometimes, you know, just your attitude in life makes a big difference, you know. So I had another friend, he was a genius. I don't know if IQ could measure his, and he did the same thing that I did. Went through his orals and he answered every question except that uh, he was kind of arguing almost. And so the board finally got the question so hard that there was no way he could answer. Now think about this. What's the difference between you and me in finance? Is it that I'm more intelligent? Not a bit. The difference is I have way more experience than you. I've seen many things that you haven't. And obviously, when you have a board of 9 or 10 faculty, they've seen way more things than any single person could see. And so they drilled him and failed him. You know, so it's just a matter of your attitude. But I remember this one. When I see this, it just reminds me of that probably the low moment in my career when I actually said something that I hope none of you would say, and that would be choose the one closest to the cost of capital. There's no such rule. I made that up. So no such rule. No such rule. Don't choose the one. This is I mean, it's mathematically correct, but it does not provide any information for you to make a decision on this. So why don't we, let's copy these. We're going to play with this a little bit. I'm just going to show you a couple of features of Excel. So just take it down to 1 and 2 here, if you would, just down to, you know, these first 2 columns down, these 10 cells anyway. And you don't have to drop them in the upper corner of a new file if you don't want to. If you want to keep your notes straight, maybe you could. Whoops, that's not the one I wanted. Yeah, we can. I don't care. We'll put them up here if you want. That's the way I show them, I guess. Okay, and I'm going to blow this up so you can see it. All right. And so we'll replicate what we saw in there. We're going to say equals NPV. And we'll do 10%. And of course, yeah, that's fine. And then you highlight cash flows 1 and 2. And then close it. And then add back cash flow 0. And we get a negative NPV. So let me move that over. Oops, NP Victor. There we go. All right, and then we'll do this the standard Excel IRR. Equals IRR. And we just simply highlight the cash flows. Nice function. Actually works like you would prefer it to work. And I get the 25%. All right. Let me give you a moment to catch up. Is everybody able to do this so far? I'm going to give you just a little bit of time. I know it's not easy.
Can you go back to the NPV, the equation?
Sure. I surely can. Let's go here. You know, sometimes these cells, you know what I'm going to do, if you don't mind? It won't hurt a thing. I'm going to move these down so I don't get that issue, you know, where you can't see the cells. Okay, so here it is. So equals NPV. First argument is your discount rate. And then just highlight all of your cash flows beginning with cash flow 1. 1 and beyond, not 0. And then close it, and then add back to it your cash flow 0. Did I answer your question?
Yes, thank you.
Okay. Thank you for asking. All right. All right. So if you were in Finance 320 and you stayed awake and your professor said use the NPV method, you You did this, you're done with this problem, you have the right answer, and all is good. Okay, we're just going to take it a couple steps further. All right. Now, one thing about the IRR argument is that if you notice, it says values and then guess. And it is literally a guess. All right. The trouble with multiple IRRs is that sometimes you will get an IRR which is an imaginary number. I think I had one many years ago, like it was 4 times the square root of -7. And that's not going to work. So they can be imaginary numbers. Sometimes they're terribly impractical. Another IRR might actually be a negative discount rate, which makes no sense. So the practicality of these IRRs, these multiple IRRs, sometimes is very limited. And you'll see this one here is actually not terribly practical. But here you put a guess in. So you have to search for this other IRR, just like I would. And I'm going to say, let's say I think it's higher than 25%. So I say 35%. I hit enter, and it went back to the first one, didn't it? So now I get a little more desperate, and I'll go up to, let's go up to 135%. I'm just picking numbers, right? That's far enough away. It found 400. So that's the second IRR here. That's your second IRR. And so this has 2 IRRs. And then, of course, there's the Descartes' law that says, the number of solutions is equal to the possible solution is equal to the number of sign changes. So we go negative to positive, positive, negative. Yeah, we have two IRRs in this problem. And I think you can see that just to show the weakness in the IRR method, whether it's 400, let me shrink this a little bit. Maybe we can get this in here. There's 400 or 25%. Those are both very high rates, aren't they? And once again, the NPV method cleaned this up right away. Well, let's go through another little feature of Excel we can use. And there's 2 ways you can do it. So if you would go to your data ribbon, and I don't know how many of you have this, but I have installed on mine something called Solver. And if I go to, in case I haven't installed it yet, if I haven't installed it yet, I can, I go to options. So I go to, let's go back again. So I go to file, and then I go to options. And in the options, you'll see something called add-ins. And now this is something interesting that Microsoft has done. They're pretty good at, instead of developing a feature themselves, they simply buy the company that has the feature. So they bought a company years ago, and now it's part of their software because they bought the company, but nonetheless, they have a add-in. And so don't click that, click the Go button. And then just check the Solver add-in. Just check the Solver add-in. You say, okay. And now that Solver will appear on the data ribbon right here. Now what I have done, let me show you what I've done, and you should be able to do this yourselves too. If you find yourself using certain Excel functions on a very, very regular basis, and Solver is one that I use frequently, I just simply give this to right mouse, and it's very light. You can see it. It says add to quick access toolbar. So if I click that, which I already have done, it puts it right here for me. So anytime I want Solver, I can stay in my home ribbon. So I have all my editing functions, and then I can go to this little question mark arrow type thing, and I can click on my Solver. All right. Now, in 2004, I took a 5-credit class on Excel, And I'm just kidding you. In 1990, I went to the director of computing. I said, "Can I have a copy of Excel?" Because he at the time, this is way back when, mind you, 1990. He said, "You don't need that. You never will." I said, "Okay." So I bought my own. And then I just happened to say, "Oh, how about a copy of this thing called Windows?" And he replied, "This school will never use Windows." I said, "Okay." So I bought my own copy of Windows. Well, anyway, once I got the Excel, I started playing with it, and I found the solver thing. Now, it used to come automatically there. It was there. Just you open up Excel, there's an option called solver. It used to be in the tools. But anyway, now what they've done recently is I think many people on the network have laptops, and maybe you don't want everything installed. So it comes now not as a default, but now you have to install it separately. And we've done, if you follow me there, you've done it. But I just started reading. What does it say here? Set objective. That meant nothing to me. Okay. And then, in fact, let me reset this just real quick. Oops, didn't mean to do that. Let me reset this. I'm going to reset all. So I'm starting from scratch. It says set objective. That didn't mean a lot to me. And then I read next to it, says, do you want to maximize it? Do you want to minimize it? Or do you want to set it to a value? So I said, well, that must be a cell that I'm trying to find an answer. So I said, well, that looks good. So I'd like this NPV cell. So I'm going to say set this NPV cell equal to a value of, and the default value of is 0. That'll work. And what would you allow solver to change to accomplish this objective? And I would allow it to change the discount rate. All right, and this make unconstrained variables. Now I find this one sometimes gets in the way. Now I can't tell you theoretically or conceptually why that makes a difference. I just experience using solver, and then I'll hit solve, and right away solver finds the 25%. Okay. Now I know there's a second one at 400%. So how could I use solver to find that second one? Well, I'll call up solver. And then the next thing I noticed when I was playing with solver, it says subject to the constraints. In other words, what answers are you willing to accept? You can put down here that it can't be negative. You can in several ways, but we're going to do a little better than that. We're going to add a constraint to this answer. And I hope this works. It might not. Well, let's make sure it works. We're going to say that this number here, this IRR, I'm going to say it must equal or exceed, let's say 100%. So I'm looking for an answer that's more than 100%. If I've guessed wrong incorrectly and there's nothing out there, it'll just simply say no solution. Okay. And then I say okay. And then I solve it. And it finds the 400% for me. Okay, the other way is we can always use the what I call the old-fashioned religion, and that would be to let's discount these cash flows. So it's this one divided by 1 plus the rate, and we lock that. Raised to the, and then this is 1 year away, so we'll just use this one that we already have here rather than typing a new one. Okay, and then I'll discount this one back 2 periods. And then we'll just bring in the cash flow 0. And if I add these together, that's a representation of 0 in Excel. All right. Okay, now what I can also ask Solver to do is the exact same thing. Let's go back to our 10%. And of course, I'm getting a negative 376, 86.78. I can simply ask Solver to set this number equal to 0 by changing the discount rate. Okay, so this time we'll try the Solver again. And we'll say that I'll change my, yeah, that's right. But this time I'm going to change the, my objective is this cell to a value of 0 by changing, and the rate is correct. And I'm going to set the rate over 100%. I could do that, but you know what? Let's just try a little cleaner. Oh, I didn't mean to do that. I keep forgetting. You double click that, you get a solution. I just want to edit that. So change is what I wanted. Yeah, I know. Oh my goodness. Okay, here we go. Change. And I'm going to make this instead of 100%. Well, we know we have one at 25, so I'm going to try 26%. So this discount rate must equal or exceed 26%. And I'll say okay, and if I solve it, let's see what we get. And it found the 400. So you can use the solver for just about anything where you're trying to accomplish a certain calculation and its value is unknown. You have to solve for it. Well, that's what solver's for. So anyway, on an exam, would I ask you to find multiple IRRs? I will not. But I would ask you to be able to identify under what conditions I might expect more than one IRR. And that would be, again, Descartes' law, saying that for every sign change, so there's one sign change, there's a second, I can expect, or I have the possibility of two solutions. Okay, and again, many times you get a trinomial, binomial, trinomial equation, and you solve for the roots, and if you'll get a negative discount rate. Makes no sense. You might get again an imaginary number, 4 times the square root of -7 or something weird like that. So I guess, but I'm just pointing out the weakness of the IRR method, the fact that you can get more than one answer. And I hope you don't ever give anybody the same answer I gave my examining board. In fact, it was so bad, I'm not sure they knew enough to tell me it was crazy. So anyway, okay, let's see. I'm going to stop for a minute and just take a look. Do we have any questions so far on this?
Would you mind showing the formula for the discounted IRR numbers? So not the 5,000, but the other one.
Okay, sure. Okay, so which are we looking for? This one?
Yes, thank you.
Okay. So I'm just doing straight discounting, just like a mathematician who never took a finance course would be doing. So I'm just taking 1 plus R. It's just the present value of a future value. So 5,000 is the future value. 1 year from now, I discount it back at this rate. Did I answer your question?
Yes, thank you.
Okay. And then, you know, the thing is, if you lock the right cells here, so I don't lock the 1, but I do lock the discount rate, then I can just copy this down, can I? And away we go. I cannot tell you that I don't know how many of you have taken cost accounting, but in cost accounting, you have they'll give you a problem where you have 3 equations and 2 unknowns. So you get a system of equations, and they'll ask you to solve for the variables. And I had a faculty member who taught cost accounting asked me how I would do it, and I did it with Solver. And the funny part was, I got a different answer than he did, and then he was teaching the class. And it turned out that the problem, the way it was stated, had more than one solution. But this is a very handy tool. If you take Finance 326, you'll find exactly how handy it is. So anything else I can answer about what I've done so far? And again, this is not for tests. This is for your own learning, and maybe a tool you can have in your to your avail when sometime in the future you need to do something like this. But what we need for the exam purposes is that from here to here is one sign change, from here to here is a second sign change, two possible solutions. Okay. All right, let me check in again. Anything else I can answer? That was a rather harsh and quick introduction to Solver, but nonetheless. All right, let's. If you would please, would you find an area you can work with, and let me show you what I'd like you to copy down. Oops, those are good. So let me just empty this thing real quickly. Yeah, if you could make 2 copies of these series of cash flows. All right, so we have an S and an L, and as it shows, it's a minus 100,000. This one's minus 60. Okay, this one's the same. And then we have year 0, 1, and you know that Excel, of course, will fill these in for you if you just drag it and bring it. Okay, and then over here, we have a minus 200. This is not in your lecture notes. I'm very sorry about that. I actually decided to include it because I knew I have way more time in Chapter 5 than I will in Chapter 6. And we will use this technique in Chapter 6. So since it's related to IRR and NPV, let's go through it now. So minus. Okay. And here we go again. So what I could do is you can just simply take this column and copy it. And then, oops, oh, sorry, don't do this one. We're not ready for that yet. Make this just another 60,000 for now. Okay. So once you have this, just repeat it and make a copy of it over to the left here. So I'll copy it. There you go. Looks good. Okay, did I give you sufficient time to create these cash flows? All right. Oh, you know what? Let's see. Hang on a minute. We got a 4. 4 and 2. That's right. 2, 3, 4, and 2. Yeah, I don't know what I got this 5 and 6 here for. We don't need those. All right. And let me just describe what we have. We have a situation whereby we have 2 methods of accomplishing some task. The initial cost of the large investment is a negative 200,000. It will require operating costs of 33,500 for the next 4 years. So this particular option gives you 4 years of service. Another option requiring less initial investment has an initial cost of 100,000 and it will operate for 2 years with operating costs of $60,000 per year. So it's a lower initial investment, but a higher operating cost. Right? And we are to choose which way or which of these should we apply to accomplishing this, whatever the task is. Right. Now, first thing I hope you see, it should stand out, is that we don't have a sign change. These are all negative, they're all costs. So anytime you're working with a problem that has all costs, if it has all costs, then IRR is not feasible, and that's because why? You need a sign change to have a solution. There is no sign change. I mean, you can see it. Equals IRR, I'll highlight all these, and of course it'll say, well, I'm not sure what it says, to tell you the truth. It's some kind of an error message. Oh, pound sign, no. That's a good one. There's no solution. So we will not use the IRR method for these types of problems. Okay? The only one to use is the NPV. So why don't you take a few minutes and calculate the NPV for each of these options. So let's start here. NPV, and I'll let you do it first, and then I will do it. All right, I'm going to do it myself now. So I'll say equals NPV. I will pick the rate, and I'll lock it, of course, because I'm going to do it for the next column. And here I'm just going to save myself some time. Even though years 3 and 4 are blank here, I'm going to continue them all the way down. That way I can just copy the equation verbatim for the next option. And then plus the initial cost, which is displayed as a negative number. And I get 204 and so on. And if I were to do that for the more capital intense option, I get 306. I think when I first started using this problem, I was reading an article comparing Mazda manufacturing compared to, at the time, Toyota. And I say at the time, I mean, it was still the same Toyota company, but Mazda was more into robotics than was Toyota. Toyota was well known for their high quality labor force, and they would use a larger labor force and lesser robotics, whereas Mazda used more robotics and less labor. So this is kind of the same thing. So if I made the huge investment in robotics to start, I would have lower labor costs. If I made a relatively smaller initial investment, and so on. So which way would we go here? Right. Well, the NPV rule is very distinct. We don't change it for anything. We choose the project with the highest NPV. In this case, the highest NPV is the least negative, and therefore that would favor the smaller initial investment. Okay. The problem here is that I'm investing $100,000, paying $60,000 in operating costs for the next, and I'm getting a total usage of my $100,000 of 2 years. Okay, here I double the initial investment. I get lower operating costs, but it lasts 4 years. So does NPV compare these two on a comparable, on a common basis? And it really doesn't. So one way you could do this, one way is to say that 2 S's are equivalent to 1 L. Okay, so I can fund 2 S's with the same capital it would take to fund 1 L. Okay, so what we'll do is we'll fund S here, last 2 years, and at the end of the second year, we're going to fund it for another 2 years. So at the end of the second year, I'll have $60,000 in operating costs, plus an additional $100,000 to refund it. Okay, so we're going to come over here and do that. So I'm going to say minus 60. Okay, that's the second year of operation on this original equipment that we purchased 2 years ago. And then I'm going to renew it, plus an additional $100,000. Okay, then this capital will last 2 years. All right, now these two are equivalent, aren't they? I'm getting 4 years of service out of this option. I'm realizing 4 years of service out of this option. Now they are on common ground and I can compare them. So we'll one more time just do our NPVs. And if we have locked all the cells, we should. I think we have. Yeah, just the rate's the only thing that's common. We can just take these and move them over to here, copy them right over to here. Oops, that's my fault. Yeah, so you just, I can do it again if you'd like. So equals NPV. Rate would be the same 10%. Cash flows 1, 2, 3, and 4. Plus cash flow 0. And then this you certainly can copy over. All right, so anyway, it gives us a completely different story, doesn't it? Once these are on equivalent grounds, so once we stretch them both out to 4-year projects, the L project will have the lowest present value of the cost or the highest NPV. All right, what if I gave you, we have 2 ways to accomplish this. One is a 7-year and one is a 9-year investment. So to get these equivalent, I'd have to compare 9 of the 7-year project and 7 of the 9-year project. So I have 63 cash flows I'd have to work with. It gets to be cumbersome, so we won't do that. Let's go back to here. All right. And we're going to create something called the equivalent annual cost. I sometimes call it equivalent annual rate, equivalent annual cost. We'll do that. And let's give that a left just. Right, and what that does is we have an upfront cost and we have operating costs that occur over the life of the asset. So a question you'd ask is, well, what's this costing me equivalent every year when I combine these costs? What's it actually costing me each year? All right. So what I'll do then is I will first we'll work it, then I'll show you how it works. So let's do an EAC. EAC. And what I do is I take this total, this NPV, and I convert it into an annual cost. So in other words, we're going to go from a present value and we're going to create a payment. Okay, so I'm going to say equals payment. So I'm going to create an equivalent annual annuity. Some people call it EAA, the equivalent annual cost in this case. So the rate will be 10%, and we will lock that. And for the first one, there are 2 periods. And let's see, our present value will be the 204 number. Okay, and I get 117,619. Okay. So 204, 132, 23, and you know what? Since these are all costs, and I know that the payment function needs a sign change to be valid. So what it does, it supplies the sign change itself. It flips the sign to positive there. We're going to put a negative in front of it just to make sure that we know that these are costs. So the equivalent annual cost is 117,000. We can do the same thing for the L project. Okay, but keep in mind I have to adjust the number of years to 4. All right. So let me just show you what we're doing here in effect. Oops. Let me do that again. Okay, so I'm saying this is an equivalent annual cost for 2 years. So if I spread this out for 2 years, and so this is a cash flow year 1, this is cash flow year 2. I spread this out for 2 years. And then if you found the present value, you could say equals NPV, 10%, and highlight these, the comma, and highlight your cash flows. Go right back to this number, don't they? And so for this option, 306,190 today is equivalent to 96,594 at the end of each of the next 4 years. And if we did the same thing, equals NPV. Of course I'll get this number. All right, so 96,594.16 at the end of each of the next 4 years is equivalent to $200,000 today and $33,500 at the end of each of the next 4 years. These are equivalent. That's why I call it an equivalent annual cost. So I've found a way to combine the effects of an initial capital amount plus an annual cost. into one number each year. Right. So this way I can see that I would choose the L version of this of these two options, the L version. Okay, and this is called the equivalent annual cost. So you basically take the present value of all the costs and convert it into an annuity equal to the life of the project. So this is a 4-year annuity, and it's equal to this cost. All right, are there any questions on this? Let me sneak back to here. Do you have any questions? All right, it looks like we not seeing any. Let's return here. Okay, we've done the multiplier IRRs. We have done the I've discussed Descartes' rule of signs. Okay, and I went through how to search for that second IRR. And again, just to reemphasize this one more time, I will not ask you on an exam to find multiple IRRs. You'd be responsible to find one IRR, but certainly not a series of cash flows that would have two possible IRRs. Okay. All right, and this is all the solver. You can do this on your own if you weren't able to follow me today. All right, so this is your assignment. You have 3 problems, questions 11, 12, and 13. Okay, no options this time. Don't do these on a piece of paper and then take a picture of it. No, I'm accepting only Excel files for this one. Okay, so work these 3 problems on Excel. For each question, create a table, a table similar to Table 2 and a graph similar to Figure 1. All right, for your discount rates in the first column of the table, I want you to begin with 0, as we always do, and then extend it to the next increment of 5% past your highest IRR. So, for example, in question 11, you should have a highest IRR of 11.87%. Therefore, for your different R values, or on your x-axis, I would like you to go from 0 to 15%. So do you see that? So looking past 11.87, where's my next whole increment of 5%? Well, it would be at 15, wouldn't it? So I'll go from 0 to 15% in increments of 1%. Number 11, okay, I want you to skip to do what it says in the book. I want you, you can answer the questions, but don't do it the way they ask you in the book. They ask you to draw a graph and use discount rates of 10, 20, and 30%. Okay, well, let me go back to the origins of that particular method. Back before financial calculators, before Excel, how did you find IRRs? Well, one way of doing it was actually to graph different discount rates and graph the NPV at different discount rates and find where, and eventually you'll have a data point below the horizontal axis. Well, anyway, you draw a line connecting all the dots, and you can see approximately where it crossed the x-axis. We don't need to do that anymore. We have Excel, we have financial calculators. So I want you to do what I've suggested here, and that is to, what I'm asking you to do here, and that is to actually graph these out. All right. Okay, but when you get to number 13, it's a bit different. I want to make sure you understand what you're trying to accomplish in 13. If I go back and ask you what's the purpose for all this IRR, NPV methods? Why are we learning them? Of what importance are they? Okay, well, if a company is to make a capital investment, what's a capital investment? It's a certain amount of money that will generate cash flows. It's a possible investment. So how do you know whether or not to make that investment? Well, you estimate your cost of capital and you discount the cash flows at the cost of capital. And if the NPV is greater than 0, it suggests you make the investment. If it's less than 0, you don't. So the purpose is identifying capital investments. Right? Now, problem 13 is not that. We have a shipyard that already has, and they've done this analysis previously, I hope. But anyway, they have a contract, and I think you'll see that it's it looks like they did some kind of analysis. But anyway, they have a contract, a signed contract to build a ship, a small cargo ship, and they can complete it with a single shift in 2 years by investing $250,000 and then an additional $250,000. And after those 2 investments, by the end of the second year, they will be paid $650,000 for the ship. All right, and here's where you got to be careful. You see that the 2 shifts, you can finish it in 1 year. So if you move to 2 shifts, instead of $250,000 at the end of each of the next 2 years, you have $550,000, and then you get paid $650,000. All right, and then the question is asking, at what cost of capital will I be better off with 2 shifts compared to 1 shift? All right, and I want you to just work this problem like we have any of the others. So take these cash flows, and you'll get. But I made a suggestion here, a little bit different, but not that much. And that I want you to run, and this is on Excel, so it isn't that difficult to do. Run your discount rates out from 0 to 100%. Okay, so when you graph this, so we have the 3 options here, 2 options and a differential. I want you to graph these just like we did any of the other problems, except extend your discount rates all the way out to 100%. And it's not that difficult if you use 1% increments, but I think you could probably get away with 5% and even maybe 10. Okay, but then what you'll see when you do your graph, you'll actually see the 2 IRRs. Okay, and what will have the 2 IRRs? Well, it will be the differential cash flows. You see, because you go from 300 positive to -9, that's 1 sign change. From -9 to a positive 650, that's 2 sign changes. All right, so that will have 2 IRRs, and you can see that the differential cash flow profile will actually cross the origin twice. So you can kind of see how multiple IRRs work. And so you find the rates at which you would use 1 shift, and at what rate would you start to use 2 shifts. Okay, and I'll just throw one little hint out at you. The point at which you'll start using 2 shifts, this is no longer a positive NPV project. Okay, basically what you're going to find, if you do it correctly, is that 2 shifts become necessary only to reduce your loss. Once the cost of capital gets to be so high, this is not a positive NPV investment anymore. And you'll actually reduce the amount of the negative NPV if you move to 2 shifts. But go ahead and graph it out. You'll see it. I hope you'll see it anyway. If you have any trouble, get back to me in my office hours. Okay, so I'll close with any questions that we might have. Any last minute questions? Oh, I'm sorry. Could I show C12? Oh, it looks like Megan has that already. Let me go back and do that, make sure we got it. C12. Yeah. Hopefully you were able to just copy B12 over 1 to the right. Okay. Anything else I can answer? I appreciate people in the class that are willing to answer a question if I don't get back to my screen here often enough. That's very nice of you. Thank you. So are we okay on C12? Between mine and her answer, are we good enough? I hope we're okay. All right, so that's all I have. I will see you on Tuesday. We will start estimating cash flows on Tuesday. All right, so I'm going to head out. Enjoy your weekend. Thank you. Goodbye.